Okay, hello. So here is an honor topic for chapter 7 for algebra 2. This is finding the sums of infinite geometric series. So when we typically find the sum of a series, it's just adding up all the different terms in those series, having the start of the summation notation, the top of it, on top of the sigma, would be your ending term, and the bottom of this would be where you start at. That's your starting term. So my starting term is 1, but my ending term is infinity. So think about how we would do that usually. If to say this was starting term is 1, ending term is 5. We would find the first 5 terms of that series and add them all up. Super easy because it's just 5 terms. There's not a lot to do there. When it becomes infinite, it's impossible for us to find the infinite term of that series. So we no longer can find that just by hand. And instead, what we have to do is use a formula to help us find the sum of an infinite kind of series. So again, this is specifically for a geometric infinite series. So when we do that formula to find this, the sum, we take our first term divided by 1 minus our ratio, okay? And if you remember when we write these terms, it would be our first term times r. So in this case, whatever term is right here would be our A1, and then right here would be our R, okay? So if I want to find the sum of the following summation, and starting term is 1, ending term is infinity, so it's an infinite series. It's set up with a geometric type rule. So I know it's geometric for the fact that it's an A1 times R with a power up here to the what would be n minus 1. I and n are interchangeable here. So I want to pick out 2 things. The 2 things I need to find this sum would be my first term and my R value. So in this case, my first term, or A sub 1, is 5. My R is 0.8. So to find the sum of this, I need to take 5 divided by 1 minus 0.8, which gives me 5 divided by 0.2, which is 25. Okay, that is 25. So again, to find that sum of that series, it would just be using this formula if it's an infinite geometric series. One thing to note is your R value. I don't need to write this down, I can just say it. Your R value cannot be larger than 1. So 5, 6, 4, 6, 1, 6, that's an okay R value. As soon as you go over that hump of 1 to maybe, I don't know, an R value of 7, 6 or an R value of 1.01, you will no longer have a sum to that series, okay? Again, the ratio here has to be less than 1 in order to have an infinite sum for this series, okay? Really quick short video just showing you how to pick apart the pieces of this infinite series and put them into that formula.